and this is assignment 11A, unit 11, assignment A. And we're going to be talking about finding angles that are formed when two parallel lines are cut by a transversal. There we go. There we go. Now my pen's working. Okay, so we're going to talk about what those words mean and what's happening. But when we have parallel lines, we can get some interesting angle relationships formed. And so we're going to talk about that. The first thing we're going to do is we're going to review a little bit of content from 7th grade in order to just kind of prepare our minds and just remind ourselves about some stuff. Before we were talking about right triangles. So in Unit 9, we were talking about right triangles. And remember, a right triangle has a 90-degree angle in it. And we usually symbolize a 90-degree angle with a little box in the corner. And we say, hey, this is a 90-degree or a right angle. In a rectangle, there are four, or even in a square, right? A square or a rectangle, there are four 90-degree angles. And so we say, hey, if we add up all of the angles in a square or a rectangle, there is 360 degrees. And so a square and a rectangle add up to 360 degrees. Another shape that the angles add up to 360 degrees is a circle. That's why when somebody like spins all the way around, if they do a trick or something like on their snowboard or their skis or skateboard, they call it a 360, right? They spin all the way around because a circle is 360 degrees. And why is that the case? Because, four 90-degree angles essentially in a circle, right? And so we could say, hey, a straight line is half of a circle, right? And so a straight line is 180 degrees. Anytime I have a straight line, that angle that's formed is half of a circle. And so a straight line is 180 degrees. Okay, so what is another shape that's 180 degrees? Well, if I'm thinking about squares and rectangles, half of a square or a rectangle, right, is a triangle. And so triangles are another shape that all of their angles will add up to 180 degrees, if I add up all of the degrees. And we use degrees to measure angles, angle measurements. We use that. The measurement that we use is called degrees. Okay, so there are some interesting things that we've talked about. This is just review from 7th grade. And then we said, hey, the next thing we need to know is this word transversal. And a transversal is just a line that crosses through another line. And so you can add that to your notes as a good vocabulary word for this unit. The transversal is just a line that crosses another line. And when we have two transversals crossing, here we have two transversals, these angles that are formed are kind of special angles because any angles that are straight across a transversal from each other are the same number of degrees. And so if this angle on the left-hand side is 30 degrees, then the one straight across from it on the right-hand side is 30 degrees. We call those vertical angles, and we're going to talk about those today. That's one angle relationship that we're going to talk about today. We call them vertical angles because they're straight across from each other, straight across the transversal from each other. And okay, so we were talking earlier about how a straight line, the angles add up to 180 degrees, right? So if this is a straight line here, and this little angle here is 30 degrees, then what about this big angle here? How many degrees is that going to be? Well, that would be 180 minus 30, and so that would be 150 degrees. And because it is a vertical angle to this angle over here, that angle would also have to be 150 degrees. And if you're kind of doing the math or thinking about this, all of those angles together are making a circle, and so they should add up to 360 degrees. And so if I add all of those angles together, you can see that I'm going to get 360 degrees. And so now there's another proof that circles are 360 degrees. All right, so what do we call it when two angles are equal to each other? Vertical angles are equal to each other. We call those angles congruent. Congruent, that word means equal or the same as. And so we say, hey, angles that are straight across the transversal from each other are congruent. They are the same. They're equal to each other. So there's another good vocabulary word. We have one more vocabulary word that I'd like to add here, and that vocabulary word is the vertex. The vertex is where two lines come together to make an angle. I like to call it the corner because a lot of times it makes a corner, right? So if I'm looking at this triangle here, the vertexes would be at the corners. See how that works? This line comes together with that line and makes that angle. And so where two lines come together and make an angle, that is the vertex. So in this picture here, the vertex would be right in the middle. So that one didn't necessarily make a corner, but it did make a corner with that angle and then also with this other angle that's on the other side, right? Any place where two lines come together to make an angle, those are the vertex. So on this rectangle over here, I would have 4 vertex. They're kind of the corners or the point. There we go, the point of an angle. All right, so there's some good vocabulary. We're going to kind of move on in our notes. Now, in your notes, your boxes are empty. I've colored mine in, and you can pick 4 colors. This is a good coloring activity. You can pick 4 different colors. If you don't have colors with you, you could, let's see, put some stripes in there and say, hey, those stripes going that way are going to be adjacent. Stripes going this way or polka dots, right, are going to be vertical. So there's a way that you can kind of mark your angles. We're going to do a little bit more vocabulary. This is just review from 7th grade. Some things that we need to remember about angles. The word adjacent, if I live adjacent to someone, I live next to. And so adjacent angles are just next to each other. Here is our nice 90-degree angle. And I'm going to color him in red because he is next to this angle over here. And so they are adjacent to each other. We call those adjacent angles. Now I could have picked this guy here. I'm going to save him for a minute. We're going to color him in a different color, but that angle would also be adjacent to my 90-degree angle. Complementary angles add up to 90 degrees. So complementary are like a couple of different angles where their angle measurements add up to 90 degrees. An example of complementary angles would be this angle here and the one right next to it, right there. See, those two angles right there are making up this 90-degree angle that's over on this side. And so if I said, hey, this angle right here is 60 degrees, then this angle up here would have to be 30 degrees. They would have to add up to 90 degrees because they're making this 90-degree angle over here. Oh, I should put that in black, right? They're making that 90-degree angle over there, those two angles together. Complementary angles add up to 90 degrees. The next one we said, hey, any angles that are straight across the transversal from each other are vertical angles. And vertical angles are congruent or equal. the word congruent means equal to each other. They're the same measurement. So if I took this angle right here that was part of my 90 degrees, but just this one angle here, and went straight across the transversal, this angle that's straight across the transversal would be its vertical angle. They're straight across from each other, and they would have to be the same measurement. They're equal to each other. So this angle over here would have to be 60 degrees as well. The last one we want to talk about is supplementary angles. Supplementary angles add up to 180 degrees. And remember, 180 degrees makes half of a circle, right? And so these two angles that are down here that are making up that nice half circle shape, they're supplementary angles. Now these two angles just happen to be adjacent to each other. They're next to each other. But supplementary angles and complementary angles don't necessarily have to be right next to each other. They could be apart from each other, but if I'm saying angle A and angle B, if they add up to 180 degrees, they would be supplementary. So not all supplementary angles are adjacent angles, but these two happen to be adjacent to each other, just so we can kind of see that they do in fact add up to 180 degrees. And if this one is 60 degrees over here, then this angle right here would have to be 120 degrees. So the big angle over here would have to be 120 degrees because those two angles add up to 180 degrees together. They're supplementary. Okay, so let's talk about some angle relationships. I'm going to kind of fill this in a little bit quickly, and then we're going to go through and just review what we talked about, okay? Corresponding angles are, we're going to kind of start down here. Corresponding angles are the best friends of angles. So here's our transversal, and today our goal is to talk about these angle relationships that are formed when I have parallel lines, because we get a lot of these special angle relationships when we have parallel lines. So here's my parallel lines here and here, and this line up here is my transversal, and we're going to say this is the left-hand side of the transversal and this is the right-hand side of the transversal. So all of this space that's over here, let me just kind of highlight for a minute. All of this space that's over here on this side is going to be the left-hand side of the transversal, and all of this space that's over here on this side is going to be the right-hand side of the transversal. So I just kind of want to have you guys kind of see those two sides, because in a minute I'm going to talk about why we have the names labeled the way that we do for these angle relationships. Okay, so the first one we're talking about are corresponding angles. And corresponding, if you're thinking about what that word means in the real world, remember corresponding is kind of like two things that are alike. If one thing corresponds to the other, they're kind of alike. They're doing the same thing at the same time, right? They're going in the same direction at the same time. And corresponding angles, I like to say they're the BFFs of angle relationships. They're the best friends forever because they're going in the same direction. If I look at this angle here and I look at this angle here, can you see how the arrow of that angle is kind of pointing in the same direction? They are the same angle, and they're both on the left-hand side of the transversal. So they're both over here on the left-hand side, and they're both on top of the parallel line, right? They're both on top of the parallel line, and they're both on the left-hand side of the transversal. And these are not the only corresponding angles. There's another set of corresponding angles here and here. You can see those arrows are pointing in the same direction, right? There's another set of corresponding angles here and here. Those arrows are pointing in the same direction. And so there is one more set of corresponding angles here and that arrow points that direction, and here. So on the parallel lines that are being cut by the transversal, there's more than one set of each of these angles. And so as I go through, try and find another set that would kind of like match. Okay, so corresponding angles are alike. They're the best friends. They're going in the same direction. Oh, I better change back to red so we can see this. Going same direction. And they are also the same measurement. So let's say this one was like 120 degrees, right? Then the other corresponding angle, because they're essentially the same angle, right? They are the same measurement. So these are congruent. They are equal to each other. Okay, the next relationship we want to talk about are alternate exterior. If I'm thinking about in my mind what this word alternate means, the word alternate means opposites. And what does this word exterior mean? It means outside. And when we name angle relationships, we're usually referring to the transversal first and then to the parallel lines. So opposite means opposite sides of the transversal. One is going to be on the bottom left-hand side, and one of them is going to be on the top right-hand side. They're opposite sides from each other. So opposite sides of the transversal, and then outside the parallel lines. So part of the name refers to the transversal, and part of the name refers to the parallel lines. Opposite sides of the transversal and outside the parallel line. So if you're looking at these parallel lines, let's just kind of highlight here really quick. This area in between would be the inside of the parallel lines. This space out here and out here would be the outside or the exterior of the parallel lines. Okay. Vertical angles we just talked about. We said, hey, vertical angles are straight across the transversal from each other. Vertical angles are straight across from each other. Ooh, I think I'm putting these in the wrong. I got to make sure I put them in the right place here. Vertical angles are straight across the transversal from each other. So this angle is straight across from that angle, straight across the transversal from each other. And, I missed part of this. Remember, vertical angles are congruent. I forgot to tell you guys, they're equal to each other. Alternate exterior angles, alternate, right? The two orange angles here, they are also congruent to each other. They're the same angle measurement. Forgot to tell you guys that. So alternate exterior angles are also equal to each other. So let's kind of think about this for just a minute. If this angle over here was 120, then because this angle is on the same straight line, this angle over here would have to be 60 degrees because those two angles, the red angle here on the left and the orange angle here on the right, would have to add up to 180. And because alternate exterior angles are equal to each other, this one would have to be 60 degrees as well. And if you're looking at this, those two angles together make a half circle, and so they should add up to 180 as well. And then we said, hey, vertical angles are Vertical angles are the same measurement, so this would be 120. And if we're looking at this, hey, those make a half circle, and so 60 plus 120 is another 180. So kind of starting to see the pattern that's developing when we have these parallel lines that are being cut by a transversal. Okay. Sorry. Went too far there. Okay, so the next set of angle relationships, same side refers to the transversal. So same side of the transversal. And interior means inside the parallel lines. Same side interior angles. Remember, part of the name refers to the transversal, and part of the name refers to the parallel lines. So same side of the transversal inside the parallel lines, and these angles, same side angles, are supplementary to each other. These angles add up to 180 degrees. Same side angles, alternate angles, remember, they were equal to each other. And so same side angles add up to 180. So if this angle were 60 degrees, and it is because it's a vertical angle from the orange angle here on the bottom, then this angle up here would have to be 120 degrees. And you can see, hey, it's a vertical angle up there as well. So look, we're starting to see those really cool angle relationship patterns that are happening here. All right, alternate interior. Well, the word alternate, remember, means opposite sides of the parallel lines. Oh, I gotta stop doing that. Okay, opposite sides, and interior refers to the parallel lines, so opposite the transversal, and inside the parallel lines. I'm going to abbreviate that because I'm running out of room. And remember, alternate angles were congruent to each other. They were the same measurement. And we can look and say, hey, this one is 60 degrees down here, so this one has to be 60 degrees up here as well. And so alternate interior angles are congruent. They're equal to each other. We're going to review this again in just a minute with our next page so that we can kind of have another look at some of these angles. Okay, the last one is same side exterior, same side of the transversal. And I'm just going to put a T here for transversal, and exterior outside the parallel lines. Same side means that they're going to add up to 180. They are supplementary. And we can see, hey, this one was 120, right? And this one up here was in fact 60. So same side exterior angles add up to 180 degrees. Now this looks crazy and I got a lot of stuff going on. Let's just kind of separate this out. We'll do one more quick review of angle relationships, and so that you can kind of have this in order to kind of maybe separate things out. And we'll identify some different pairs here. So remember, vertical angles were straight across the transversal from each other. And so an example would be on this one. I'm going to just zoom in here really quick. Let's make this just a little bit bigger so we can see what we're doing. Vertical angles were straight across, so 2 and 3 would be an example of vertical angles, and 1 and 4 would be another set. 6 and 7 would be a matching pair, right? And then 5, and 8 would be a matching pair. So those are kind of our matches of vertical angles. And remember, vertical angles are equal to each other. They're congruent. Okay. We're going to go across here to alternate interior. Remember, alternate means opposite sides, right, of the transversal. I'm just going to put T for transversal and P for parallel. Opposite sides of the transversal, and interior means inside the parallel lines. Okay, P for parallel, T for transversal. So opposite sides of the transversal inside the parallel lines. An example would be 4 and 5. Those are a matched pair. Remember, alternate interior angles are congruent. They're equal to each other. Another example of alternate interior would be 3 and 6. There's another set of alternate interior angles. Alternate exterior angles. Alternate would be opposite sides of the transversal, and exterior would be outside the parallel lines. So an example of alternate exterior would be 2 and 7, or 8 and 1 would be another example of alternate exterior. Corresponding angles. Remember, those are like the BFFs. They're corresponding in the real world means alike, right? They are alike. They are angles that are going in the same direction, or pointing in the same direction maybe. And they are also equal to each other. An example of corresponding angles would be angle 1 and angle 5. Another example of corresponding angles would be angle 2 and angle 6. A good idea maybe would be pause the video and see if you can identify some numbers that would be another set of corresponding angles. And as I kind of go through these, maybe see if you can pick them out before I show you which angles match up, right? Another set of corresponding would be 4 and 8. And then the last one would be 3 and 7 would correspond with each other. And just again, to like highlight this, we can see, hey, 3 and 7, 3 is pointing, it does not want to do that very well. It doesn't want to highlight very well. But you can see 3 is going that way, 7 is going the same direction. Do you see that? Those arrows are kind of pointing the same direction. Sometimes I have a lot of students that get stuck on corresponding angles on how to identify those. So I kind of like to show you guys and make sure that you can see that angle relationship. And they are equal in measurement. They have the same number of degrees. Okay, same side exterior angles then. Remember, same side refers to the transversal. They are on the same side of the transversal. And exterior means outside the parallel lines, right? So the outside of the parallel lines. An example would be 8 and 2. They are on the same side. They're both on that right-hand side of the transversal. So that would be an example of one set. And another set of same side exterior would be 1 and 7. They're outside the parallel lines and they're on the same side of the transversal. And remember, same side angles are supplementary. They add up to their degrees, add up to 180 degrees, and we call that supplementary. Okay. Let's move back over here. Same side interior angles. So same side of the transversal. I'm just going to put T for transversal. And interior means inside the parallel lines. P for parallel. An example would be 4 and 6. Now you can see we are in between the two parallel lines. Another example would be 3 and 5. And those also are supplementary. they add up to 180 degrees. And the last one is one that we haven't talked about, but we kind of have, but we haven't, right? The last one is a linear pair. And the word linear, remember, it has its name says what it is. It makes a line. And so a linear pair are on the same line together. They make a straight line. Let's say that. Make a straight line. They make that nice half circle, right? They're like two angles that make that nice half circle. They add up to 180 degrees. They are supplementary to each other. And so an example of a linear pair would be 1 and 2. And they're right next to each other. They're kind of on that same line. They make that nice half circle shape. Another example that maybe you might not see right at first would be 6 and 8. They're also a linear pair because they are on the same line together. They're kind of next to each other. They make that nice straight line together. So there's a couple of examples. You can see if you can find another linear pair. There are a few more. But just so that you know, a linear pair make a line. They are also supplementary. And we've talked a lot about supplementary angles. Remember, supplementary angles are just angles that add up to 180. And you can see that by our angle relationships, there are a lot of different kinds of supplementary angles that add up to 180. And don't forget the word congruent. We could add that congruent angles are the same measurement. They're equal to each other. So just like supplementary, the other term that we're using today is congruent angles, and they are equal to each other. So there is some, just separated out so you can kind of see some different examples of the different types of angle relationships that we have. The last thing that I want to talk about real quick is kind of how I determine what an angle measurement would be. This is kind of how I set it up. I use like a little equation, right? So let's say I had a pair of angles and I knew one angle, but I didn't know the measurement of the other angle. So what I do is I figure out what relationship do those angles have to each other. Are they vertical angles? Are they same side interior angles? Are they corresponding angles? So first I determine what their relationship is, and then I kind of set it up like it's a little equation. I say, okay, if they are the same measurement, if they're congruent, then my first angle, whatever it is, has to equal my second angle. So let's say my first angle was 30 degrees and they were vertical angles. Well, vertical angles are equal. They're congruent to each other. And so the second angle, angle number 2, would have to be 30 degrees as well. If I have supplementary angles and they add up to 180 degrees, then angle 1 plus angle 2 has to equal 180 degrees, right? And so I would say something like, oh, if my first angle were 30 degrees, right? Then I know my second angle, whatever it is, it's question mark, it has to equal 180 degrees. So 30 degrees plus the question mark or X, we can use a variable, or I could put angle 2 or, whatever I am thinking, but I kind of think about it like it's a little equation. How do I figure out what X is? Well, then I would have to subtract 30 degrees, right? In order to figure out that X is equal to 150 degrees. So that's kind of the idea that I use, or the kind of way that I think about how do I figure out what the missing angle is. If it's congruent, then angle 1 has to equal angle 2. If it's adds up to 180 degrees, then angle 1 plus angle 2 has to equal 180. And so I kind of feel like I kind of set it up, or I kind of think about it in my mind like it's a little equation that I'm solving. So hopefully that kind of helps you guys see it. We're going to skip over this one today. And let's kind of put that into action, right? Let's put it into action. Let's find some angle relationships here. Oh, I'm Really big. Okay. All right. The first thing is use your notes to help you decide angle relationships. Maybe a good idea would be try this on your own. See if you can find the angle before I tell you what it is. So angle A. If I'm looking at angle A, right, the angle that I know over here is 70 degrees. If I'm thinking about my angle relationships, then these two angles together, you can see they make that nice half circle shape. They're on the same line together. And so I would say, hey, these two angles, angle A and angle 70, are a linear pair. And I know that linear pairs are supplementary. They add up to 180 degrees. And so my angle 70 plus angle A, it has to equal 180 degrees. So if I want to know how many degrees angle A is, then I just subtract 70 from 180 and I figure out angle A is 110 degrees. And then I go to the next angle and I say, okay, angle B. Well, if I'm looking at this, I can see angle B is a vertical angle. It's straight across from my 70 degree angle. So I say, hey, it's a vertical angle to the 70 degree angle. And I know that vertical angles equal each other. So angle B has to be 70 degrees. Angle C is also a vertical angle, but angle C is a vertical angle to angle A. And so angle A was 110 degrees, we decided. So angle C has to be 110 degrees. And we just kind of go down through and we kind of identify, hey, what are the angle relationships and how can I use that to help me figure out what the measurement is? Let's take a look at angle D. What do I know about angle D? Well, maybe I said, hey, it's a corresponding angle with angle A, right? It's corresponding, and I know corresponding angles are the same measurement. Or maybe I said something like it's a alternate interior. So there's more than one right answer sometimes to these. It's alternate interior with angle C. And so I know that alternate interior angles are equal to each other. So angle D has to be 110 as well. And then we could say, oh, wait, look, angle F is a vertical angle to angle D. I can see that right now. And so it has to be 110 as well. And then, oh, angle E, there's my linear pair, right? Or I could have said, hey, angle E is an alternate exterior angle to my 70 degree angle. So there's lots of different angle relationships we can identify here. Let's use a different angle relationship since we've already used vertical. Let's say G is an alternate interior with B. And so it has to be the same measurement as B. And then we found all of our missing angles. Try this on your own. See if you can do it. I'm going to go through it pretty quickly just so that this video isn't super long. And the rest of the notes are just practice. So this is about as far as we're going to go. I like this one because we have to do a triangle in here. We have to think about, 12, 15, and 18 make a triangle. So let's just start with what we know, right? My 130 angle, I know vertical angles, right? 130 and the number 3, they're vertical angles. They're straight across. So I know vertical angles are the same measurement. So angle 3 has to be 130. And then maybe I could say, hey, 3 and 4 are a linear pair. They make that nice half circle. They're on the same line together. So 130 plus 50 equals 180. So I know that's 180. And so then I can say, hey, angle number 1 is vertical, so it has to be 50 as well. And I'm just kind of using my angle relationships to help me figure these out. I also know 4 and 9 are alternate interior angles, and so 9 has to be 50 as well. That makes 12 have to be 50 because it's a vertical angle. And I can say, oh, hey, look, angle 10 and angle 3 are also alternate interior angles, right? And I could say, maybe I could say something like angle 1 and angle 11 are same side exterior, and so they have to add up to 180 degrees. There's some angle relationships. And I can do the same thing over here on the orange line as well. I can start by saying, hey, number 15 is a vertical angle from the 70 degree angle. And angle 16 is a linear pair, so it is 110. 16 and 8 are corresponding, so 8 has to be 110. And 70 and 6 are corresponding, so it has to be 70. And the 70 degree, number 6, angle number 6, right, is straight across from angle 7. So they're vertical angles. They have to match up. Angle 5 is straight across from angle 8. They have to match up. And angle 13 is across from angle 16. It has to match up. And so now I've found all of those missing sides. How do I get down here, though, to 18, 17, 18, 19, and 20? Well, I have to recognize that these 3 angles here are a triangle. And if we talked about at the beginning of class, hey, triangles also, their angles have to add up to 180 degrees. So if I have a triangle, then 50 plus 70 plus, we're going to say question mark number 18, right? Because we don't know what that is. We don't know what that is. That has to equal 180. 50 plus 70 is 120 degrees, plus whatever angle number 18 is. And so 180 minus 120 is going to tell us what our missing angle is, 60 degrees, right? Angle 180, I better put the 60 over there so you know what I'm doing, right? 180 minus 120 is 60 degrees. So now I can say, hey, angle number 18 is 60 degrees. And it's vertically straight across from the 20, right? So this one also has to be 60 degrees. And 20 and 19 are on the same line together, so they have to be add up to 180. So this one has to be 120. Which makes this one 120 as well. And now I've found all of my missing angles. And all I did was use angle relationships in order to be able to figure out those missing angles. All right. Make sure you stay in communication with me and Mrs. Zeider and email us if you have any questions. We're happy to help. Good luck, guys.